Just like to thank everybody for joining today. Today we're actually going to look at, how Pure Storage is enabling, JupyterHub as a service and leveraging our FlashBlade platform. So, quick introduction. The speakers today, myself, Paul Bruton. Quick introduction. I'm a modern data architect here with the ANZ business for Pure Storage, and have Andy Parsons, who's going to be talking to the bulk of this deck today, and he's our new stack architect, and Andy has an APJ role. So I'm going to flick over to the agenda. I wanted to keep it pretty succinct today, and what we're going to really have a look at here is, what are the challenges in delivering, Jupyter as a service. And these have sort of come from a lot of our customers out there that are leveraging, some are leveraging FlashBlade, some are leveraging, Jupyter, and they were wanting to understand how they could make that process a little bit better for their researchers, their data scientists, their developers. So we did a lot of work within our labs here within the APJ region for a few of our customers, and we've got some great feedback from it. So, we'll look at the challenges in delivering Jupyter as a service, and we'll give you an idea of what we've done. And how we want to do that today is basically how we built it. And we're also going to look at how you manage and monitor it. It's pretty important, not only using, the platform, but how you manage it and monitor it and get that granular feedback of how your users are leveraging it. And then finally, we'll wrap it up with how you use it. We'll give you a bit of a demo. Everybody says you shouldn't work with children, you shouldn't demonstrate stuff live, but we're going to that today. We will give you a demonstration of what we built within our labs. So the challenges, a lot of the challenges that our customers have fed back to us and they're facing, and this first one is extremely relevant, for the current times that we're in, is remote access. How can we provide or enable remote access to our researchers, to our developers, to our data scientists, and how can we provide that remote access through a standard web interface, to come in and do their work? Scalability, how can we scale this environment up? How can we look into disaggregation and give us the ability to scale, say, my compute environment independently of my underlying storage infrastructure? And then the last one, which was driven by a couple of large, research organizations that we work with here within ANZ, is the challenges around sharing data sets and the challenges around sharing large data sets. When we start to move into the data science, into the research space, we're typically dealing with data sets, potentially in the tens, the hundreds of terabytes, and potentially even into the petabyte realm. So how can I give my researchers, my developers, my data scientists access to, not only internal data sets, but maybe some external data sets, which they want to leverage and share across the organization. And with that, I'm going to basically hand it over to Andy now, and he's going to step through the solution overview and what we've built here within the Solution Center. Andy, over to you.
Yeah, let me see if I can take control of your screen there.
There we go.
Cool. Hey guys, thanks for joining. Yeah, so I think that it's appropriate to start out with the from a solution overview perspective and talk about the FlashBlade. Like Paul said, one of our customers had workloads in data science using Jupyter Notebook, and substantial high performance compute environment and lots of different use cases. And they had pain points around performance with serving those workloads to those resources. So they came to us, how can we help? How can you help us improve this experience? So to talk about FlashBlade a bit, this is a scale-out NAS, and with a few key features. Obviously, one of them being the high concurrent parallel throughput capability, which allows multiple concurrent workloads without latency constraints, and it offers NFS S3 and SMB protocols, so pretty wide array of offerings available, and a scalable architecture that can accommodate the footprint. So we can scale it as the needs grow with no impact or outage, non-disruptively. And that's really the core of this, this infrastructure. And let me see if my, my mouse works. Let's see. Sorry, I'm having, there we go. And then if we look at PSO as a layer between Kubernetes and our FlashBlade. Now, PSO is a container storage interface plugin, or CSI, for Kubernetes, which allows us to consume our Pure storage in a sort of a service-like offering. It leverages a few key features around smart provisioning, elastic scaling, and transparent recovery that really automate that process. And it allows all the services in Kubernetes, be it Jupyter, Prometheus, or anything that needs persistent storage, to be able to automatically provision storage from within that product, from within that FlashBlade. And then with Kubernetes, what we're doing is, this allows us to leverage the power of that orchestrated cluster to automatically scale, and with our disaggregated storage, it can be scaled independently of compute in memory, and vice versa. So as the need for more users, maybe you're onboarding users, maybe you're adding a department remotely, and you need more compute, you can scale that without having to add storage. And likewise, if you are adding storage, maybe you've got another data set, we can scale that array with no impact to the cluster, and it will automatically grow, leveraging that PSO. Now, I'm trying to, there we go. So from a Jupyter perspective, we put Jupyter inside of Kubernetes as an easy to manage deployment of Jupyter Notebook that's, again, scales automatically and can be updated, simply with Kubernetes, with kube commands to make changes as needed. And then we publish the offering via URL so that anybody internally or externally can access it, making it, a great environment for remote access for engineers, be it inside of a university, and to VPN users, to scientists outside of the organization. Now, if we talk about integration, we sort of talked about PSO already, for the CSI, that container storage interface. And Pure's also built integrations into Prometheus with a FlashBlade exporter and a FlashBlade client exporter. So the ability to pull metrics from the FlashBlade around utilization and performance, and then client metrics. So we can look at the data that maybe our users are using. So we can see hotspots. Maybe a user is using a lot of resource. It helps us to track that down. And then we've also pre-built dashboards in Grafana to allow you to take those metrics and put them in a dashboard and have a visual representation. So much easier to visually see those issues. And then lastly, we've actually embedded our RAPIDFILE toolkit into our Jupyter image, which can take full advantage of that high concurrent parallel throughput. It's a tool set that Paul will actually go into a lot more detail later on in this presentation with his demo. So now let's talk about how we built it. This is sort of a diagram of the infrastructure in our lab. And we've kept it incredibly simple from an infrastructure perspective. This actually mirrors very similar to one of our customers as well. We've got a FlashBlade, and you can see here it's got a 160 gig of throughput with the ability to add up to 320 gig. So accommodate pretty much any workload. It's connected to a pair of switches with 40 gig interconnects into a chassis of servers. And so each one of those servers has got a management network and a storage network. So we've actually created a dedicated storage fabric from compute to storage. So every container or every notebook session would have that 40 gig network throughput capability up to the FlashBlade. So there's no constraints around performance all, from end to end. And then to go into a little bit more detail around Jupyter Notebook, this is actually deployed as via Helm, which is kind of like an app store for Kubernetes. So you publish them and you can pull these applications down and then deploy them into the cluster. A Jupyter Notebook is deployed as a thing called JupyterHub in this app store. And what it does is it takes all the components of Jupyter Notebook and it puts them into like a hub container, like kind of a brain of the operation, and then a proxy, which exposes that web API for users to onboard in. And as a user is authenticated into the environment, they'll get a container assigned to them, and that user can get access to a data set, and then we've set it up with PSO so that user also gets a persistent volume or a home directory on that FlashBlade. So think from a scaling perspective, when you've got hundreds, if not thousands of users, having the ability to automatically deploy all this on the fly in a scaled environment is very important. And these are all, since we're leveraging this Kubernetes as an orchestration platform, we let the orchestration tool do all this. And so each user would have, as we grow it, will have that same experience. So I would log in, I would get access to the data set, I would get access to my own persistent volume, and so on and so forth. And PSO actually gives it the ability to, you can grow those home directories automatically. You can tombstone those. Maybe a user goes away and doesn't need to be in the system anymore. You can automatically have it set to remove those directories as well. And that's sort of the Jupyter Notebook deep dive. And I think I might turn it over to Paul now to talk about monitoring and management.
Thanks, Andy. I think we've got one more slide that I probably want you to talk to, Andy, and it was probably a little bit more granularity into the solution integrations with Pure. I think you touched on them on that solution overview slide.
Yeah, yes, sure. So, the important note here, this with CSI is this is built to the Kubernetes spec, meaning it's built to work on all architectures. So, so that includes Kubernetes, D2IQ, Rancher, Platform 9, OpenShift, even VMware, or Tanzu, Project Pacific. So it's an open source certification that our software dev team is constantly evolving to improve and add features. I think last week we released 5.2, which adds some features around volume resizing and read-write many capabilities with FlashArray. And then from a Prometheus perspective, we've built, sort of as I said before, is these exporters that can create a service inside of Kubernetes to scrape the FlashBlade for metrics, built by our data science team in Mountain View, and fully supported to work with Prometheus. And then lastly, Grafana dashboards, which are JSON configs. Now, all of these are available at on GitHub. They're not soft. There's no licensing. They're open source. They're free for our customers to use with our products.
Thanks, Andy. I've actually got a slide towards the end of the deck, which we've got links to all the resources that we've been talking to throughout this presentation. So, the idea would be to send this presentation out, following the session today, so everybody has access to that. But moving on to how we monitor it, and Andy's sort of done a good job there of giving us an overview of our integration into Prometheus and Grafana. And this is just to give you a little bit of a visualization of what we're actually doing here. So we talked about pulling in the FlashBlade metrics. So this is we can see on the screen here we've got visibility of latency, IOPS, bandwidth, and IO of how the FlashBlade is performing. So it's the ability to visually see how the FlashBlade is performing, as an underlying solution. We also have the ability, and this is a great one that our customers, love, is the ability to have, visibility of the individual clients that are leveraging FlashBlade. We can see, there's a lot of IP addresses that have come up here, but it allows you quickly to identify potentially clients that are, outside the norm. We can sort of see over here with the client read IOPS, we've got there's a client spiking well above the norm, that we can sort of, see with the majority of the clients there, and is peaking, at around about 200 million. So, that may be something that I want to drill down into a little bit more detail and work out what that particular client is actually doing, and we can sort of see, we've same with the writes, we've got quite a number of, clients which are, above the norm, and our latency is going pretty good, so the ability to have a look at that individual client that's leveraging FlashBlade, is great value. It allows us to drill down, pinpoint potential issues. The next one is also the ability to granularly drill down into the individual Jupyter Notebook sessions. So as your researchers, as your developers, or your data scientists are firing off their Jupyter Notebook session, also have the ability to look at, what they're doing and what resources they're consuming, how much memory, how much CPU usage, maybe what the network, IO is. And again, it just rounds out the solution to give you visibility to solve issues if they pop up, or, literally give you visibility in what everybody's actually doing, and doing it in more of a collective way. So looking at the FlashBlade, having a look at the client metrics, as well as the individual Jupyter Notebook sessions, so all that, as Andy said, is generally available to import into existing, Prometheus Grafana environments. There's no real work there. Bring our exporters in, bring the JSON files for our predefined dashboards, and away you go, trying to make it all simple. So that brings us onto the RAPIDFILE toolkit, which Andy mentioned earlier as well. And I thought I'd just run through a few slides to give you a little bit of an overview of what the RAPIDFILE toolkit is before I actually demonstrate it as we round out the session. So this is something that our internal teams developed, and it was really created to drive the parallelism that FlashBlade can deliver. Andy talked about, the high throughput and the parallelism that the technology delivers. And, it relates back to some of these standard Linux core utilities, so that's your LSs, your finds, your removes, your copies, the DU commands, etc., etc. I think we have about 7, which I'll list in, I think, one of the next slides. But let's have a quick look at, if we were doing a recursive list, of what typically would happen with these standard Linux utilities. So as we start to kick off and we go into our top level directory, and as now we start to drive down into these, subdirectories, we can see it's a very serial process with respect to how these commands work within the Linux world. And, this takes time, especially when we now relate this back to what I'm doing as a developer, as a data scientist, as a researcher. And, I'm trying to, look at the data set that I'm potentially wanting to leverage, for my research, my development type work. So I'll continue to build this as I think you can get the process. It's serial. It starts to move through everything in a serial nature, And it can take a lot of time sometimes to get your results back from you leveraging some of these standard utilities on the data set that you're looking at. Now, in contrast to this, when we move over to what we call our RAPIDFILE toolkit, and really what we've done is we sort of use the term we've purified them, so we now have a PLS rather than just an LS. The way that the RAPIDFILE toolkit works is it starts to leverage that parallelism. So as we start to look into that top level directory and we go down to the subdirectories, you can see we're now starting to do things in parallel rather in serial nature. As we drop down into the subdirectories under that, we start to execute things in parallel and so on. So really what we're seeing here is a significant performance improvement in leveraging these standard tools, which we use a lot, from a data science and from a research and from a developer's perspective against our data sets. And especially when we're trying to look at, potentially the metadata associated with this data as well. And, here's a great example of what one of our customers is seeing around some of their data science and their AI and their machine learning workloads. And what they're looking at doing here is loading, metadata, so reading 3.2 million files, and you can see the results on the screen there. We're talking about 1,214 seconds versus, let's call it 10 seconds. 1,214 seconds is, my maths is correct, it's probably 20 minutes. It's about 20 minutes versus 10 seconds. So you can sort of see what that would do if you're a researcher, or a developer, working on some of these larger data sets, and what it actually can mean to you, being able to, get these results back of what you're trying to do and load data, do some data exploration in 10 seconds versus 20 minutes, that means a lot, when you're starting to look at how can I reduce time to results, for my analytics workflows. So what we typically see with a lot of our RAPIDFILE commands is, with our default settings is, about a 20 times performance improvement, which is quite significant. We've got sort of the list of commands there, which we've, in essence, purified at this point in time under the RAPIDFILE toolkit umbrella, ls find, chmod chown, du, rm, cp. So with that, I'm actually going to stop sharing this PowerPoint presentation for a second. So this is my Jupyter notebook session that I've actually logged into, and you can see when you come in, the way that we've configured this is, we get a look from a notebook perspective. We've got some Python capability, we've got some console, and we've got some access to our standard terminal as well. And I'll jump in. Actually, let me just kick off a new terminal. I'll just give you a look at some of these commands here. So, if I look at what I've got mounted into this session, we can see here that here's my shared data set. So this was one of the biggest challenges that we've seen with a lot of our customers. And in the polling questions, there's a lot of, people agreed with this is how can I get access to shared data sets, for my researchers and my developers. Then I've got my home directory here as well. If I, I'm just going to CD, into my shared data sets, and let's have a quick look at it. And you can see here I've got, this is the data set that I'm going to be predominantly using today. It's this a Stanford campus data set, and we'll sort of run through a standard, machine learning labeling type process against a bunch of, imaging based data. I've also got an Enron email data set here, and we like to use this one because this is, millions of small files. And what I might kick off now is to give you a bit of a look at, how one of our RAPIDFILE toolkit commands work in a sense, and it's the find command. And this is a comparison towards a traditional find versus, leveraging pfind. So I'm going to kick that off against the Enron email data set. Now you can start to see these working in parallel. Now, keep an eye on the count here, which I've just highlighted. We're already up to 2 million, 2.5, nearly 3. I know there's about 5 million files here, and you can see we're probably going to be finished. There we go. We just completed, so it took us 17 seconds to find 5.2 million files within the Enron 5M dataset. Now our traditional find is still chugging away. We're only up to 40,000 files it's found at this point in time. We're going to let that run because I know it's going to take a bit of time. What I'm going to do now is just give you a bit of an idea of how our developers and our data scientists are using this technology. And one of my colleagues has actually shared with me a JupyterHub session, and they want me to have a bit of a look at what they've done against the Stanford campus data set. So I've just uploaded that from my laptop into my JupyterHub session. And probably what I'll add is that the JupyterHub session that I'm leveraging here is in our Singapore lab. I'm based in Sydney, and I'm accessing it through my NBN connection from home. So I'll give you a bit of an idea of this is the concept of I'm a remote user into this environment. I'm going to open up my data exploration session. So this is typically what a data scientist is doing in helping refine their code, refine their algorithms, to sort of the machine learning process to start to run their algorithms across potential data sets. So I'm just going to step through here. What I'm doing here is I'm just loading a bunch of applications that I need to start running this process. You can see here, this is my shared data set. So this is the data set which I now have on FlashBlade, that when I open my JupyterHub session, I have access to. We've sort of seen that over here in this terminal session. So I'm using this Stanford campus data set, which I get access to. So I'm just going to execute the ability to tap into that. Now I'm going to today work on frame 441, which is one of the images in there, which I'm trialing, some of the work that we've done. And what this is going to do is apply some axis to an image, so we can see that's come up there. So I've got an image, frame 441, out of a data set of hundreds of thousands of images. And I've zoomed in a little bit on a particular area, just to make sure that, they were some people. So I've applied my axis. Now the next stage of this is I'm sort of moving into the labeling, process. We've got some data sets around our labels that have been created that I want to apply to an image. So I'll come down here and I'll kick that process off. Again, we can see here I'm accessing my shared data set, and I'm dropping down into one of the subdirectories and looking at my annotation, material. So I'll apply that, go and have a look at the coordinates that have been generated, with respect to these annotations. And we can see here initially I've got, about 153,000 rows of data here, which is, as a data set, it's a little bit large for what I'm wanting to do right at this minute. So I want to strip this down and apply it to just the frame that I'm working on at the moment. We can see it's very responsive, it's very quick here. So for that frame that I'm actually working with, what do we got there? There's about 6 pedestrians and a biker, within that frame. So now I want to sort of, label, that image. So I'm going to apply that labeling. Going to set the process off to creating, the bounding boxes, and let's go and have a look at, how that labeling has been applied to that particular imaging. And this shouldn't take too long. And it'll pop up, and here we go. So you can sort of see here, I've very quickly, grabbed a shared Jupyter session that one of my colleagues is using. I've got access to the shared data set that we're using, and I'm just, iterating through the workflow and the process and some of the code that's been started to be developed to apply a labeling process to, these hundreds of thousands of images that we want to apply the algorithm to, the larger data set at a point in time. And what did we say? We had about 6 pedestrians. What have we got here? 1, 2, 3, 4, 5, 6. And there's my biker over here in the top right-hand corner. So the process seems to be working, and it's accurate. We've been able to label the pedestrians and the bikers of that particular image. So that gives you a bit of an idea of, how we use, the Jupyter Notebook, as a service, accessing it from Sydney out of our Singapore lab, being a remote worker. Having access to my standard terminal, we can actually see here, to give you the power of our RAPIDFILE, we're only up to 2.8 million files at the moment. It's been 5 minutes, we've gone through the whole Jupyter Notebook session, and, the RAPIDFILE toolkit actually found that data set in 17 seconds. We'll let that continue to run. We've got our shared data sets. I've got my user home drive, my scratch space, so it becomes a pretty powerful platform, to be able to deliver this capability. So that's probably it from a demonstration perspective. I'm just going to minimize this and pull the presentation back up as we sort of wrap this out. We'll go back into presentation mode. I swap the display. So Andy, can you see that again? Yep, thumbs up. So
thumbs up.
So hopefully that gave you a good visualization, from a demonstration perspective of how the Jupyter, or how somebody would use the Jupyter Notebook as a service capability, and then some of the benefits, with that greater ecosystem that we as Pure have developed with respect to FlashBlade, our Pure Services Orchestrator. So what I'll just, round this out, and I'll, sort of to summarize what we sort of set out to do, and, what we're trying to address from a challenge perspective. And it was really that remote access, the scalability, and how we sort of get access to those shared data sets. So this is as an ecosystem of capability, it's really cloud optimized, and it's ready for, modern data as a service. We sort of showed that we can access this via a web browser. I have access to, large data sets, sitting there, within a repository, out of our Singapore lab, from Sydney. Simplicity. A lot of this, once you set it up, is just automated. I know Andy, you might be on mute at the moment, but you've rebuilt this, a couple of times, and I think you've got it down to about, 30 minutes to be able to, set this entire environment up.
Yeah, roundabout.
Yeah, so, being able to, deploy and automate, deploying this in, a very fast time. And then really, Andy talked about a lot of the, the simplicity and ease of management, which then comes from, the automation, which is delivered through Pure Services Orchestrator, sitting on there in the back end as well. So simplicity is a key part of, addressing these challenges. Performance, tuned for everything is really our motto around FlashBlade, the ability to support, what we sort of term as multi-dimensional workloads. It could be very metadata intensive, small files, billions of small files, through to large, throughput streaming workloads. Is, FlashBlade has really been designed to support all that. And you've sort of seen, the power of how quickly we can do some of these things, with our, things like our RAPIDFILE toolkit as well. And then finally, that agility, the ability to scale these environments with that multi-protocol support. This is probably one of the biggest things that we're seeing with these type of environments, is our customers wanting to start to disaggregate, compute from the underlying storage infrastructure, so, they can scale those environments independently of each other. And, as Andy sort of showed, the ability to scale, that Jupyter Notebook environment, from a containerized fashion, very quickly. Multi-protocol support, we've been predominantly using NFS here for everything today, with respect to, the Kubernetes leveraging, the volumes, the NFS volumes off FlashBlade, but the product also supports S3, and we're seeing a big shift within the analytics application environments of leveraging, S3 buckets as well as traditional NFS file systems. So you're sort of future-proofed there with respect to that multi-protocol support that the platform delivers. And with that, I mentioned earlier on the resources. So from a resource perspective, everything that we've sort of spoken about today, we've got listed here. So, the JupyterHub session, I know, Andy, you might want to chime in here. Is that the Jupyter Notebook instance that we've been leveraging today?
What's that?
On the GitHub we're talking about now.
Well, the GitHub that in your list here from top to bottom, so the GitHub repo, that is the repo that I used to build this deployment. It's based on CentOS. So the repos for JupyterHub and all that stuff are in this documentation. It's actually end-to-end documentation. Code is where we store a lot of our code around Kubernetes and our open source projects. So you can link back to the GitHub repos there. The exporter is actually published on our external GitHub, which is that Pure Storage Open Connect. And then Grafana, the Grafana is as well. I think I just may have sent you the wrong one. This is one on my internal one that I use to build it, but it's the same. And then the last is the blog that has a kind of an end-to-end deployment of PSO, Kubernetes, and JupyterHub. Or actually, I take that back, PSO and JupyterHub.
Yeah, so that's a little bit of a plug for Andy. Andy's done a lot of work with helping build this environment, and his blogs are a very good read. I think there's 2 parts to the blog now, which if you jump onto this part of the blog, you'll be able to get to the second part, from there. So that's us just about wrapped up. How are we looking on time? I think we're running pretty good. We're at about the 40-minute mark. So I think there might have been a few questions that came in. I'll just leave that up for the time being. Let me have a look at the Q&A. This is probably a question for you, Andy. Can this work on Docker?
Jupyter Notebook absolutely can work in Docker. We've built it in Kubernetes to leverage the orchestration power and that scalability. So Docker would be, typically, I think a lot of people probably started out with Docker and would run a Jupyter Notebook on a Docker node. But when you're talking about hundreds of nodes, the ability to scale and manage all that, having that orchestration piece with Kubernetes is what gives it that power.
So with that, I might, sign out and thanks